Hello, welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest math SAT problems of this year according to Prep Maven. In this video, we'll be looking at problem number 8, which is kind of a tricky one. It says, the equation 24x squared plus 25x minus 47 all over ax minus 2 equals negative 8x minus 3 minus 53 all over ax minus 2 is true for all values of x not equal to 2 over a, where a is a constant. What is the value of a? Negative 16, negative 3, 3, or 16? So I'll start by writing out this equation. So we have this stipulation that x cannot equal 2 over a, and that simply comes from these denominators here. So we have in the denominator ax minus 2. And of course, we cannot divide by 0, so these denominators cannot be equal to 0. So these can't be equal to 0, which means that ax cannot be equal to 2, which means that x cannot be equal to 2 over a. This is part of the problem that might look kind of complicated, but it's really just saying our denominators cannot equal 0. Otherwise, we need to find what the value of a would be to make these two sides of the equation right here equal to each other. And the easiest way to see that would be to simplify this into a single fraction. And the way that we do that is we'd multiply this term by ax minus 2 over ax minus 2. So if we get that, we would get something that looks like negative 8x minus 3 times ax minus 2 minus this 53 right here all over ax minus 2. And now we see we have two expressions here that have the same denominator, which means they're equal to each other if they also have the same numerator. In order to find the value of a, which makes these two expressions equal to each other, we're really looking for what is the value of a that makes this numerator equal to this numerator. In other words, makes negative 8x minus 3 times ax minus 2 minus 53 equal to 24x squared plus 25 minus 47. So the first part of this is obviously to multiply this out. So first we multiply the first terms and we get negative ax squared. Multiply the first to the last and we get plus 16x. Multiply the last to the first, negative 3ax. And then multiply last by last, we get plus 6. Of course, we add this negative 53 term right here. And we want to see this equal to our 24x squared plus 25x minus 47. So the first thing we need to do is we need to combine like terms. We see we have two x terms here, and we have two constant terms. So if we combine those, we get negative 8ax squared plus, and then I'll put this in parentheses, 16 minus 3a. This is what happens when we combine these x values, plus minus 47, because 6 minus 53, negative 47, equals 24x squared plus 25x minus 47. And we want to see what values of a here will make this side of the equation equal to this side of the equation, which means all of the terms, the x squared terms have to equal, the x terms have to equal, and the constant terms have to equal. Fortunately, the constant terms are already equal. Negative 47 equals negative 47. So we can kind of cancel this out. We don't need to worry about that. So what we need to find is what value of a is going to make negative 8 equal 24, and is going to make 16 minus 3a equal 25. And we can solve these pretty straightforwardly. So I'll just move this up here. Here we can just divide negative 8 to both sides, and we get a equals negative 3. And here, we can first start off, we can subtract 16 from both sides. We get negative 3a equals 9, then we divide by negative 3 on both sides, and we get, once again, a equals negative 3. So this works out. We have our values of a equaling. So that negative 3 makes both this x squared term equal this x squared term, and this x term equal this x term. So our final answer is negative 3, or in other words, answer B. Answer B, a equals negative 3, will make these two equations equal to each other for all x values when the denominator is not equal to 0. So that's the video. Thank you so much for checking in, and I look forward to seeing you in the next one.